Hello, friends. Good evening once again. I welcome you to another episode of Manthan. Manthan is a platform where we try to propose an alternate model of universe based on spacity instead of a classical model of universe where the gravity rules the roost. So we supplanted gravity with spacity and applied it to almost all the systems of the universe or the cosmos, like uh, Earth and Moon, solar system and its planets, Milky Way and its stars, black holes, various systems of the cosmos. In the same series, we took up a series of interesting questions based on unexplained mysteries of the cosmos, and we tried to unravel those mysteries, and we did come up with quite a few interesting concepts to explain those mysteries. In the same series of these questions, today also we have another interesting question, bit off track, bit deviation from our usual concentration on cosmos. It's much closer home, planet Earth. But if you consider planet Earth as a part of cosmos itself, then we are not much off track. The today's question, interesting question, is about tectonic plate movement. And can they be exploited? These tectonic plate movements can be exploited for furthering prosperity of a nation. So obviously, one may think that when we are talking about tectonic plate movement, the nation's prosperity, exploitation, obviously one may think, possibly exploiting the energy that is released during the earthquake. No, we are not doing anything like that, but there for sure is exploitation, but exploitation of something different, exploitation of the river flow systems. It may look mundane, but it is anything but that. The river flow systems that we take for granted now, that we look upon it on our land masses, we think them to be permanent in nature, but they are anything but permanent. The reverse flow systems, as we see through these discussions, they change so drastically, in the sense, if the rivers were flowing now, let's say eastwards, once upon a time, the same river flow systems on the same landmass would be flowing westwards, which is exactly 180-degree change of difference. So we are now going to discuss how these river flow systems change and how they are connected, affected by the tectonic plate movements. And these ancient river flow systems, as we go through the discussions, you will see that these river flow systems leave permanent scars on the landmass that they are flowing. And we are going to see if those ancient river flow systems can be exploited to further a nation's prosperity. But it's going to be a very challenging subject, so we will have to go through point by point. Before we jump to the river flow systems, we need to understand a few concepts about tectonic plate movements. So, what is a tectonic plate movement? Every planet started as a ball of fire, and obviously over millions of billions of years, this planet cools down. And the cooling down is always from outside to inside. The outside, the terra firma that we all reside on, live on, is called as crust. And as you go inside, you have a hot solid core. The crust is cool, that is why we are able to live on it. And the hot solid core is obviously very, very hot. In between the center and the periphery, what we have is a various types of geological features. They could be hot molten magma in liquid form, and semi-molten rocks, and then the crust itself. These layers are not very well defined, in the sense you cannot say where one ends and where another starts. But for sure, they are different in nature. And hence, they are loosely bound to each other. So we have a crust on which we are uh, living on, and the crust that we see, generally they are represented by the various boundaries of the continent, but the crust does not end there. In fact, it goes beyond into the ocean floor, and generally we may feel that these crusts are, how should we say, is continuous in nature, but it is anything but continuous. This crust is very fractious. It has got a lot of fractures. Possibly when the cooling happened, the solid crust kind of contracted and these cracks developed, or possibly because you have a molten magma which is moving slowly, but moving very, very powerfully. And since there is a loose connection between the internal parts of the planet and the crust, obviously there is a resistance to movement. And this may lead to the cracking of the crust. And the various, so hence the total part of the crust is divided into various plates. And each of these plate is known as tectonic plate. And this is what tectonic plates are. And the next thing that we need to understand is that these tectonic plates, they are always in motion because of the movement of the molten magma. Obviously, the crusts also have to follow that. And the next concept that we need to understand is continental drift. When the geologists or the scientists took a look at the world map itself, and when they saw the boundaries of the continent, they seemed to be eerily matching with each other, like a jigsaw puzzle. For example, the coast of Africa and south coast of America, they seem to be matching as though they were once a part of the single continent. And when you rearrange the various continents, like South America, Africa, Indian subcontinent, the Middle East that we know of, Antarctica, and Australia, they seem to be, the continents' boundaries seem to be matching like a jigsaw puzzle. And generally, it was felt that maybe all these continents were a part of a single continent once upon a time, and they broke and drifted apart. But it was a little difficult to prove. But as and when they gathered evidences like the geological features of the boundaries, these boundaries are thousands of kilometers away. But if you go and match the geological features, they were mirror image of each other. And that cannot be possible unless these continents were once part, they were a part of a single continent. Not just the geological features, the flora, fauna, there is no way these could be the same on either side of the continents, which are thousands of kilometers away. Even the fossils of the extinct species were also matching. So it was more than given that these continents were part of a single continent, and they broke apart and they drifted apart. And this is what is known as continental drift. And this part of the continent, which as we see here, is called as Gondwana. This was when it broke, let's say around 180 million years ago. India plate moved away towards Eurasian plate, South America moved westwards, Africa moved northwards, Antarctica moved southwards, and of course Australia also southeastwards. So the timeline that you can see here is when the India plate moved from broke from Gondwana 180 million years ago. It took around 130 million years to traverse this from this point to coming and hitting the Eurasian plate. And that is when the Himalayan mountains started forming. We will discuss about that a little later. It is not just about Gondwana breaking. These continent plates are not just breaking once. This breaking and joining has been going on for time immemorial. So even before Gondwana was connected to North America and the Eurasian plate, and that continent was called a supercontinent known as Pangaea. This was even before 335 million years ago. And even before that, when you go back in time, in Hadean times, as far back as 4 billion years ago, those were the times when Indian plate crashed into Antarctica plate of Antarctica. And this is another timeline that is important for us when we are talking about river flow systems changing. Now, we talked about tectonic plates and their movements. So we need to understand that tectonic plate movements lead to mountain formation. Now, what are the kind of tectonic plate movements? Of course, there are many, but primarily three important plate movements are there. When two plate movements side or traverse by each other, this is not much of interest to us because this at best would lead to, how should we say, earthquakes and related destruction, but they do not affect our river flow systems greatly. We will see that how. But the other two movements of the tectonic plate movement for sure affect how mountains are formed. So another way these tectonic plate movements is head-on collision. So you have one part of the tectonic plate coming this way, whereas the other tectonic plate is coming this way, and they're having head-on collisions. What happens when there is a head-on collision is, of course, the earth buckles, it folds, and it raises. So if you have these two tectonic plates coming, this is where they are buckling and it is being raised. And that is how these fold mountains are formed. And these mountains, the typical mountains are Himalayan mountains. Another way mountains are formed, or another way when the tectonic plate movements move, is that let us assume that these were together and this hot molten magma is pushing it from bottom. This is a single plate together, and this magma is pushing it. That is when there is a chance that this crust yields and it breaks completely. And since the magma is trying to push, the convection flow of magma is pushing up, it is facing the resistance of the crust. Obviously, its direction changes, and when the magma moves this way, it takes along with it the continent also. So when you have two flows like this, so these two continents break and they are taken away. But what happens when this breakage happens? So possibly if you are there at that point of breakage, when it is completely broken, it doesn't happen just like that in a day, could be hundreds of years. You would see that on the either side of left and right side of yours, you would see vertical cliffs of the crust exposed. Now, obviously, let us assume that this is the plate which is being pushed by the magma and is going this way. The force which is exerted at the point of the fissure obviously will be more than the force which is being exerted here. So, and hence, this plate, it's natural for it to be tilted. And when it tilts, the vertical cliff is designed, or when it was formed, is only it is able to hold itself when it is vertical. When that vertical cliff or the side is tilted like this, the top part obviously collapses, and what we see are these mountains, and these mountains are known as block mountains. And these block mountains, Sahyadri on the western coast of India, are a very typical block mountains. Now that we have studied the tectonic plate movements, what they are, the continental drift, how these tectonic plates move away from each other, and how they form mountains. These are the three concepts that we are going to use to decide how the river flow systems flow. Obviously, what is a river flow? River flow is nothing but water which is moving. If it is stationary, it is lake. If it is moving, it is a river. And these water obviously moves towards across a slope, across a gradient, from higher slope to lower level. And it's very difficult for us when we are talking about a land mass. When you have talking about a small space, you can easily find out what is the gradient, which way the river is going to move. But when you have a land mass which is as big as a subcontinent of an Indian plate, it's very difficult to find out gradient. So how do you find which way the rivers are going to flow? The best indications are the mountains itself. So obviously, when you have the Eurasian plate and when the India plate is coming and colliding, the India plate obviously gets lifted. When it is lifted, obviously there is a slope created, there is a gradient, and obviously the rivers will flow along the gradient. So we need to understand that when there is a head-on collision, the gradient is against the direction of the collision. And when there is a block mountain, when the block mountains are formed, when the continental is broken into two pieces, that is when you have the block mountains which are forming, and the plate itself is sloped, the rivers would be flowing along the breaking point. Now that we have studied the basic concepts and how the river flow systems affected, which plate should we take for consideration? As you had seen, there are so many tectonic plates to consider. Why consider only this India plate? One reason is familiarity. I, being an Indian, I know the river flow systems and the topography. And the other one is, you will see as we go across through these discussions, the factors which exist on this India plate are so conducive. If at all you could exploit these reverse flow systems, it's possible that the factors which help you to exploit them are existing on India plate. So let us study the landmass of India, and this is what the river flow system looks like. And this is how it is with the current times. As you can see, all of the rivers of India have two options to drain into. One is the Arabian Sea on the west coast, and another is Bay of Bengal on the east coast. And as you can see, majority of the rivers which are on the India plate are draining into Bay of Bengal. Arabian Sea has only 3 or 4 rivers draining into it. If not for the local features, even these rivers would have drained into the Bay of Bengal. And that is why Bay of Bengal is less saline as compared to Arabian Sea. That is because Bay of Bengal is blessed with all the fresh water which falls on this landmass getting drained into the Bay of Bengal every year. But that means that the general direction, whatever be the local direction, the general direction of the rivers is southeasterly. And so the gradient is as though northwest and southeast. Why is that? We had seen that the mountains are a good indication of the way the gradients are formed, and hence how the river flow systems flow. So let us apply this here. So what are the kind of mountains that we have as of now is the Himalayan mountains, Himalayan range. So these are to the north of the India plate. So that would mean that the gradient would be southwardly and all the rivers would be flowing southwardly. It is not so, it is southeastern. Why is that? That's because the Himalayan mountains are not just on the north part, they are also on the northwestern part. So obviously, if it was left only to this part of the northern part, it would be flowing south. The fact that you have Himalayan ranges on the northwestern part also, obviously there is a southeasterly tilt, and that is why majority of the rivers are made to drain into Bay of Bengal and flow southeasterly. Now, this is how the situation is today. Will it be the same in future also? Obviously, as long as the India plate is crashing into the Eurasian plate and it is getting lifted, Himalayan mountains are, their height is increasing even as we speak. Very little, some say millimeters, some say centimeter in a year, but for sure they are moving up. So when these mountains height is increasing, that means the India plate is getting lifted and lifted. So when it is getting lifted, that means the gradient will be increasing. So millions of years into the future, the river flow system may have water gushing forcefully than it is now. But for sure, they are all draining into Bay of Bengal in the normal, general southeasterly direction. That is about future. What about past? So you turn the clock backwards. So when you turn the clock backwards, obviously the height of the Himalayan mountains would be decreasing. What is now 8,000 meter? You go a few million years, it will become 7,000 meter, go again 6,000. So like that, you will keep turning the clock backwards. You will reach a stage where you would be standing on the northern side of the Indian plate, and you could see possibly the Tibetan plateau on the other side of, on your opposite side. That means the Himalayan ranges are not existing. For this, you will have to turn the clock around 50 million years back. That is when the Himalayas were just about to form. This is like the India plate is just about to come and hit into the Eurasian plate. This doesn't mean that these plates are floating on sea. No. These, as I had said, these plates have always been in touch with each other. It is just that the collision that was happening undersea, where one plate was getting subducted into the other, but when the continental exposed surface above the sea level, that when they meet, that is when there is a resistance, and hence the folds, mountains are formed. So in the past, when you are standing here at this edge, you would want to look back and see what kind of river flow systems that you have, because we said river flow systems are decided by the mountains, because they kind of tell you which way the gradient is going to be. But now you have negated Himalayan mountains by going back 50 million years. That means this gradient is not available anymore for the river flow systems to follow and drain into the Bay of Bengal. So what was the situation then? So we need to, when you're going back into the past, how far back are you going to go? I have divided them into three main epochs. One is the present, where you have the India plate as of now, you have Himalayan mountains. So when you turn 50 million, when you turn the black clock into the past 50 million years, so this is where you find where you do not have Himalayas. Now you have Himalayas, Western Ghat and Eastern Ghat. But if you go to 50 million years back, you would just see Western Ghat and Eastern Ghat. Western Ghats are these and Eastern Ghats are these. So you go back. As I said, the India plate broke from Gondwana and it has been traveling along the northeastern direction since this broke 180 million years ago. And by the time it reached, this was 50 million years ago. That means this migration was there for around 130 million years, 130, 120 million years. It was migrating. And as I said, if you still go back, the Gondwana itself was a part of the supercontinent called as Pangaea. And if you go much, much back forward in the past, there will be a time when 4 billion years ago or 2.5 billion years ago, that is the range said by the geologists, that is when the India and the Antarctica plate were together or they were colliding each other. So you see what are the mountains present in these conditions. So when you have the present conditions is Himalaya, Western Ghat and Eastern Ghat. And when you go to the 50 million years ago, the Himalayan Ghat disappears. You go back 180 million years ago, Western Ghat also disappears, because this is where Western Ghat is formed when the continental breakage happens. India plate breaks from Gondwana. And when you go back 4 billion years ago, that time even Western Ghats were not there. It was Eastern Ghats only when the India plate was crashing into Australia plate. So these are the three basic epochs that we are going to study. Just to give you an idea, the Himalayas are 50 million years of age, old. The Sahyadris formed 180 million years ago. And the Eastern Ghats, which is these Ghats, are as old as the planet Earth itself. That's 4 billion years to 2.5 billion years. If you see the age of the planet Earth, this is where planet Earth started from. This is Hadean time, when there were all just a ball of fire on the planet. You had all volcanic crust. So that was 4.5 billion years ago. And when it started cooling, and that is when the India plate was crashing into Antarctica plate, that was just 4 billion years. So it is like 500 million years after the formation of planet Earth. So this is the river flow system that we have now. If I remove the Himalayas, go back 180 million years ago, what would be the river flow systems on this landmass? And you go back 3.5 to 4 billion years ago, when you do not have Western Ghats, you have only Eastern Ghats, how would the river flow system would be? Let's study those. So when there are no Himalayas here, the landmass is just connected to Gondwana and Antarctica on this side. So this is African side and this is Antarctica side. African side on this and Antarctica side on this. As we said, when the continent of India plate broke away, if you see, this is a cross section. If you take a cross section across the India plate, this is how it is. This is West Coast, this is East Coast. These are Western Ghats, these are Eastern Ghats. The Deccan Plateau itself has got a easterly gradient. And that is how the Western Ghats are going to affect the India landmass. But it is not just Western Ghat. If it was just left to Western Ghats, all the river flow system would have to be eastwardly. But you also have Western Ghat. And they are there much before the Eastern Ghats are there in existence much before the Sahyadris or the Western Ghats. So obviously, since the collapse, since the collision of India plate to the Antarctica is this way, so obviously this plate is going to be lifted this way. So you have Western Ghats pushing it this way and you have Eastern Ghat pushing it this way. So when you have these two directions, and it is not just exactly westwards, because of the slope or the angle tilt, obviously the push will be this way and the push is going to be this way. The resultant force which is going to finally decide the gradient would be northwards. Not exactly northwards, but northeastwards. So the river flow system will have to follow that, which means 180 million years ago, between when the India plate broke off from Gondwana and till it reached the Eurasian plate, all the rivers on the India plate were flowing north. We didn't have just one Nile. Almost every river that was there on landmass India would be flowing northwards. That means we had many more Niles than what you could one think of. So when you now go 4 billion years ago or 3 billion years ago, and obviously that is the time when the Western Ghats are non-existent, so the India plate will have a gradient which is completely dominated by how the Western Ghats are formed. So that would be in this direction. The gradient would be in this direction, and then obviously the rivers would be flowing northwesternly. So you can see, to begin with, in ancient times, the rivers were flowing to the northwestern position. Then they changed it 180 million years ago to northwardly, and now you have southeasternly. So what exactly is happening? The river flow systems which were flowing this way have changed their direction 180 degree. So if you superimpose all these river grid systems, and this is how this land mass is ravaged by these river flows. So as the gradient changed, the river flow changed, and you had old river flow systems replaced by new river flow systems as the continental plates decided. Now, moment you take a look at this grid, you feel like, is there any way we want to exploit this situation? But one may ask, why exploit in the first place? As I said, if at all the reasons are more conducive for this exploitation, they exist on India landmass. That is possibly because of the glacial nature of the northern rivers that flow in northern India. Whenever there are monsoons, the northern rivers usually flood the landmass. And such is not the case with the southern rivers, possibly because absence of the glacial connection. So the southern part of India is always struggling with less than required water. So obviously the Indian administration would have wanted to solve two problems with one solution, which is, if there is any way you could exploit, if you could redistribute the excess river or excess water from the northern part to the southern part, then everyone would be happy. And this is not just a concept, it is a project which is ongoing in India. It is known as river interlinking. And this is how the river interlinking looks like. What you see as blue is all Himalayan sector. And the one which you look at as red is the peninsular sector. Now you can see the number 10, which is Ken Betwa. It is such a small project, and this project is going to cost India 46,000 Indian rupees, 46,000 crore Indian rupees. And if you put up the entire project value, that is around 5,60,000 crores of Indian rupees. That works out to around 70 billion US dollars. That could be as much as 2% of the GDP of India itself. And how these projects are susceptible for inflation over a period of time, would not be surprised if it gets doubled. So if at all, if you could exploit this ancient river flow systems, you do not have to do the river interlinking by digging up the whole canals, concreting them and controlling the river flow. You could just use these grids and redirect the water. But it's easier said than done. The major problem is the river flow systems, which is shown beautifully now as grid. If it is true, if this is how the river flow system is on this landmass, why do we not see these whenever there is a rainfall? They should be following these river flow systems also. Even if the gradient is other way around, the river flow system can flow in the opposite direction. But that is not the case. Why? The grid that you see is a top view when you're looking at the landmass from the top, but they are not in the same level. The current flow system obviously is on ground level zero, but the ancient ground level systems are below it because geological forces have these over a period of millions of years that they keep adding the deposit layer by layer, and obviously what is 180 million years ago will not be on the top. So you have the current flow river system at G is equal to 0. The ancient river flow systems would be much below, and the previous one would be even below from that. So this is the major challenge, and we will see how we can make use of how we can solve that problem. But even before that, there are many more, how should we say, pros and cons. Pros, obviously, we know if at all you can exploit, if at all there are ancient river flow systems that you can exploit, it will be cheaper, faster, quicker, environmentally friendly. The benefits are many, many. But there are, just the way there are pros, there are cons also. So we study those cons one by one, and then we come to the level problem at the last, and we will try to solve that also. But it is easier said than done. The challenges are one too many. So let's take the first one. We are talking about these timelines, which is 4 billion years, 180 million years, 50 million years, assuming that the rain cycle is still there. What if 180 million years ago the rain cycle was not there? Fine, tectonic plate movements are there, the mountains are formed, the gradient is formed, but there is no water to flow. No water, no rain cycle, no river flow system. So let us see. The basic part for you to have a rain cycle is water. We possibly do not know exactly where water came from, whether it was brought in from asteroids or water was all along there on planet Earth. But for sure, the age of the water that is there on planet Earth is as old as planet Earth itself. So water has been there possibly in larger quantity than it is now. So when you have water in such quantity on the surface, obviously the seas were there. When the sea was there, and we know for sure the for evaporation to have happen, you have to have a heat source, and the primary heat source is our own star, sun, and it's been there even before planet Earth was formed. So we have had, how should we say, seas evaporating. So planet Earth has been blessed with, how should we say, a blanket of atmosphere which is basically a vaporized water. But it does not help you to have just an atmosphere. You need that atmosphere to move. And thankfully, the way the planet Earth is shaped, the equator receives more heat as compared to the Arctic polar circles. So obviously there is a temperature difference. Wherever there is temperature difference, pressure PV is equal to RT is a function of temperature. So the pressure difference is there. So when there is pressure difference, fluid, both the seawater as well as the atmosphere, moves from one place to the other. So obviously when it moves from the seas, the evaporated water in the form of clouds, when it reaches land masses, it condenses and rain cycle will take place. So that means the rain cycle possibly has been there all along the age of the planet Earth. So we do not have to worry about this. So we have taken care of first one. The second problem is the time itself. It's a great level. All the Indian folklore would know what Ganga, Jamuna, Saraswati is. Ganga is river Ganges, Jamuna is river Yamuna, Saraswati is also a river Saraswati. It finds its mention in our scriptures. It was supposed to be a very wide, forceful river flowing to the northwest of Indian subcontinent. But it was dismissed as a myth for many, many years. That when you can't see a system, river flowing like that, that means it is not existing. Thanks to the technology that we have now, which is satellite images, geologists have been able to, point out the river system emerged on its own, that this is where possibly the river Saraswati was. But the idea why I'm telling about river Saraswati is how many years old would it have been? It would have gone dry 5,000 years ago, 10,000 years ago, and it may have been active for hundreds of thousands of years. And we know how a powerful river it was. For sure, it would have left permanent scars on the landmass, but still we are finding it so difficult to find something which is a few 100,000 years maximum that you can stretch. Then we are now here talking about hundreds of millions of years. So it would be almost impossible. So time is a great leveler, and we will not be able to. This is the contra point. But the counter to that is that these ancient river flow systems are underground in nature. We were not able to find out Saraswati River because it was a part of our current times. So it was on terra firma, ground level zero. And we found it difficult because it was, how should we say, covered or hidden by the vagaries of the atmosphere. But the ancient river flow system, if at all they are existing underground. So that means they are underground and they are preserved. It's only a matter of finding where they are and how to exploit them. And the second situation is the river flow systems that we are talking about from the ancient times, they have been in action for hundreds of millions of years. So when you have such rivers, water body moving on the landmass, they would for sure have created permanent scars on the landmass, and they would for sure be there forever. It's only a matter of exploiting. And the best part of the river flow system that existed when the India plate was migrating from Gondwana to Eurasian plate is that it's because of the block mountain formation, which is the Western Ghat. And the block mountain formation happens much, much quicker as compared to 15 million years taken for Himalayan ranges to form. Agreed, it is not happening in a day. When the cliff breaks and falls down under its own weight and the mountains are formed. But surely that is not more than a few thousand years. So that means that the river flow system, which is this river flow system, was active the moment it broke off from Gondwana till it reached the Eurasian plate. That is, for 130 million years, that river flow system was active. And plus, when it is Himalayas, which is fold mountains, the gradient is slowly increasing but changing. So there is a possibility that the river flow system, whenever the gradient changes, because of the local variations, it would change its directions. The general direction would be the same, but because the gradient is increasing, there is a chance that it may look for different directions. When I say it is changing, that means that the current 50 million years river flow system that we see, it is liable for changes in direction. But look at this one. For 130 million years, the tilt which has happened because of the breaking of the two continents would remain the same as long as the magma is pushing it towards the Eurasian plate. The gradient is going to be the same. So when you have the same volume of water flow going in the same direction without any change in the gradient for 130 million years, the scar is going to be massively permanent. And what happens because of that is that the riverbeds that were existing for those 130 million years when the India plate was migrating from Gondwana to Eurasia, it was very deep in nature. It was much deeper than what the river flow system are in the present time. That is the counter to these questions of time. And another question which can puncture this concept of river flow change system is the geological forces. Generally, over a period of time, as I said, the landmass receives a lot of loose soil because of the wind or the atmosphere getting deposited on the landmass. It is moved from one landmass to the other. So over millions of years, you have got layers like this. So the layer which is the deepest can be considered as the oldest, and the layer on which we are standing, it is the youngest. Now, imagine if there are geological forces on a landmass which are cataclysmic in nature. These layers that we see here would be completely mangled. These layers would not exist at all. So we need to see whether India mass or the India plate, the landmass, has had experienced any cataclysmic geological forces in its lifetime. There are two of them. One is known as Deccan Traps, DLIP, Deccan Large Igneous Provinces. So this is where what is marked here as dark gray area was affected by the volcanic lava flow. So when you have such volcanic lava flow, you cannot expect the layers to remain as they are. For sure, they will be mangled. So the chances of exploiting this river flow system on this area would be less. But fortunately, it is only 10 to 15% area of the landmass of the India plate. So another factor is that much of the India plate, when it was migrating from Gondwana to Eurasia, generally the layering happens when you are connected to neighboring land masses. So in the sense, the atmosphere lifts the loose soil and deposits on you. If at all you do not have any landmass neighbors, obviously the chances of this layering will be there. It would be reduced because you have sea on the left and sea on the right hand side. That is what happened with India plate. When it was moving from this place to this place, obviously it didn't have any neighboring landmass. So possibly the layering, even if it is there, it would be a shallow depth, which would help us exploit even if the ancient landmasses are below. The chances are that the layering is not as heavy as you would find there in other tectonic plates. Another issue is you see the yellow marked areas. These are the deserts. And you can see it starts from North Africa, Saharan Desert, Middle East, and obviously it skims the India plate on the northwestern side. And we consider this as a cataclysmic geological forces. For this, we need to understand how deserts are formed. To understand deserts, desert is basically what? It's all sand, fine sand, bereft of any minerals, nothing can grow there. Do we see a similar structure, physical structure elsewhere on the planet? Something which is sandy, no minerals, nothing grows there. How about beaches? Beaches are also completely made of sand and it has no minerals, nothing can grow there. So how these beaches are formed? Beaches are formed because the sea hits the landmass, low tide and high tides. It keeps hitting the landmass. And when it is hitting the landmass, it is pulverizing the soil, which is the edges of the landmass, and converting it into fine sand, taking all the minerals out, making sure that nothing grows there. So does that mean that it is the beginning of the landmass? It is not so. Assume that you are standing on the beach, barefooted, you have sand below your feet, start walking towards the sea, go into the water ankle deep, you would still have sand below your feet. Go knee deep water, you would still have sand. You go neck deep, you will still have sand. That means the entire seafloor is subjected to the same forces that is subjected on the beaches. That means just the way beaches are dry in nature, pulverized sand, even similar situation exists on the seafloors. So possibly all the sea that you see here, the seafloor of all of this would be very similar to if at all you were to drain the water from the seas, all you would see is deserts everywhere. So that means the deserts that you see in the Middle East, they once were beds of sea. And this sea was possibly shallow sea. Shallow sea in the nature because the magma, there was a local magma movement just below this area. It started from here. This is the seafloor. This is the shallow sea. The magma is pushing it away. It is a local magma and it is raising it just above the sea. And what you see is the sea water gives away and the sea floor gets exposed, and what you see is complete desert. So what you see, this formation of the desert, is because of a magma movement which lifted the sea floor above the sea. And this magma movement obviously will be affecting all the nearby land masses. It would have affected India plate also, but only to the extent of northwestern area, that is here, where we have the Thar desert. So that means the India plate, generally, if you see, around 20% of the area itself is affected by the cataclysmic geological forces. So you still have a majority of the landmass of India unaffected by these geological forces. They expected that the layering would still be there. They would not be mangled by these cataclysmic geological forces. Now, the biggest challenge is how do you exploit? I have given it as a pictorial representation of this layering. Let us assume that this is where the ancient riverbed systems are. They are not here on the ground floor. They are here at the underground. Now, let me suggest you a possibility where obviously what you see here, earlier, as I said, the riverbeds were very deep, and riverbeds, the most important thing is that they also have fine sand. Wherever you go, wherever you see during summer season, if the rivers are dried, what you see is just a riverbed, but you take a good look at it, it's all sand, because river moves the soil and it keeps just the way the beaches were formed because of the continuous action of the water on the soil. In the same way, the riverbed is also getting acted upon, and all the riverbeds completely, they have sand in there in that particular area, and that's why you have sand mafia, sand mining, which happens. So let us assume that the riverbeds were like this and it is completely filled with, how should we say, sand. And over millions of years, this sand got, deposits kept happening. And what we are now situated is here. Now, I give you a proposition where I replace this sand with oil. Let us assume there was oil here instead of the sand. What would you do? You would be wondering why I'm supplanting sand with oil. One is solid, another is liquid. Agreed, they are different as chalk and cheese. But most important commonality between sand and oil is they are homogeneous in nature. One may be liquid, another may be solid, but they are homogeneous in nature. In the sense, just the way you suck out oil, you can suck sands also. You see these dredging vessels which are in the middle of the sea. You see all those artificial islands which are formed. They are not formed by bringing the sand from the landmass. No. You have these dredges which have powerful suction pumps which suck the sand from the seafloor, and it is used for forming the artificial islands. So if I tell you that there were oil here, what would you do? Even if it is a few hundred meters down below, you would drill and suck it out. And generally, what you do, and the same way, you can drill and suck all this sand out. But generally, when you do oil drilling, after sucking it out, it becomes hollow, and you do not want this roof to collapse. So you fill this up with gas, yeah, so that the terra firma does not get affected. But here, we would want this roof to collapse. You just suck this sand out, create the hollow, and leave it. Just the weight would act on it, and possibly the next monsoon itself, the entire roof would collapse. So this ancient river flow system which was there underground would get imprinted on the surface. So the entire river flow system which was underground would come up, come alive, get imprinted on the surface. And that is how you can bring the ancient river flow system, if at all it is existing underground, you can bring it up. And these sand that you're going to suck out, it is a great rich resource. That we have sands on the beach also, but it is of a very poor quality, cannot be used for construction purposes. As of now, many cities are struggling with good quality sand for construction. And that's why you see all this sand mafia, sand mining mafia happening. So this would be a veritable yellow gold, literally. If oil is black gold, this is yellow gold, and you can use it for any other means. Plus, when you hollow it out, now you have the river flow system which was underground would come up on the ground level zero. Now, it's good to say, let us assume that there are ancient river flow systems. But Indian landmass is such a huge landmass. Where would you want to go and drill? So you need to find out what are the locations. And let me take, you may have seen these fossil dig sites, even in Indian landmass plate. You would see most of these dig sites are far, far away, where there is no, how should we say, infrastructure, no inhabitants. It's in some God-forsaken place. Why is that? That is because all the extinct species, they were not, they obviously would be where, even if they were herbivores, they would be where plants are, and plants are where river flow system is. And wherever there are herbivores, there are carnivores, because herbivores come for water. But these river flow systems are not the current river flow system which are flowing southeasternly. They would be flowing northwest, northward direction. So obviously, all the lifestyle systems were along these river flow systems. So obviously, when you try and go and dig for dinosaurs, they are in godforsaken places. So it's important for you to know where to drill, where to dig, where these ancient river flow systems are there. So, what is the methodology? How do you locate the ancient river flow systems? So, obviously, we will have to take help of technology. Fortunately, India has ISRO, so we have wonderful 3D satellite imagery of the entire Indian landmass. So the first thing that I suggest is simulate that landmass. Every geographical features of the landmass should be simulated to the extent of, let's say, even a centimeter, because water, even if there is a millimeter of gradient, it would flow in that direction. So it's very important for us to have this wonderful 3D satellite imagery. And I'm sure India, thanks to ISRO's capability, we would be able to have it. Then you drain all the rivers of the current river flow system. Ganga, Jamuna, Kaveri, Narmada, all these rivers, you drain the water out of it. And then backfill the emptied riverbeds. As though if you take a screenshot, all these river flow systems should vanish. When you do that, the next step is to eliminate the Himalayas. When I say eliminate the Himalayas, it is not just a matter of removing the Himalayas. It is like turning the clock backwards. So when you're turning the clock backwards, when you're negating the Himalayan mountains, the gradient that is there now would also be negated. It would come to a gradient that was there when you were just standing on the northern part of India and overlooking the Tibetan plateau. So you should be able to eliminate that southeastern tilt which is there in the current times. You should be able to eliminate it. And then you need to simulate the plate, the slope, and possibly you do not have to simulate, because when you remove the tilt because of the northern Himalayas, what is left with is the ancient tilt, and you now simulate the rainfall on this landmass, the corrected slope landmass, and possibly you would see that ancient river flow systems that we talked about, where they were flowing northwards, would emerge. They would come to life. And if you want to do it, still go further, which is 4 billion years ago, you remove the tilt, the Sahyadri or the Western Ghats, again, you would have those northwesternly flowing river flow systems. So for the moment, if you can even exploit the river flow system that was there for 130 million years, that would be good enough for you to exploit. So you have these ancient channels coming to life. There would be a possibility that the river flow systems that is simulated, they may not exactly match with, they are only a general indication of how the river flows would have. So it is trying to reduce, how should we say, the chances of errors. But there would be error for sure. So you will have to, take out a sample area of the particular thing which is there as ancient river flow system, dig, drill, and find out with the sample that you take where exactly the sand is there as specimen, and see, you will have to recalibrate your the river flow system, so that it's very difficult to get it in one shot. But as and when you recalibrate, you should be able to simulate it on your map and then pinpoint exactly where the ancient river flow system was. And what we are trying to do is, we do not want the entire river flow system coming up. What we want is for river interlinking, we just need a few tracks, limited kilometers, which could allow you to redistribute the water from the place where there is excess water to where there is drought. The savings, as I said, could help India save around $70 billions. That is just cost saving. Can you imagine if you can have all these river flow systems coming up? The landmass would have more area to drain water, to hold water. This would have unknown benefits for the India plate. And what we are saying is, if at all this has to happen, in the sense, if at all there is a river flow system, if at all it can be exploited, it can be done on India plate. And once if it is tried over here on India plate, and if it is a possibility, this could be applied to almost all the land masses, all the tectonic plates of the world, especially the global south, the African continent, the South American continent, the Australian continent. These are the continents which are in a way affected. Even the global north also can be tried out. But these would be great savings if we were to exploit this. That is Manthan today. Thank you for listening. Good night.